everyone. Thank you very much for staying late for this talk. And thank you, Sasha and Raphael, for providing great feedback for the presentation. So I'm a postdoc in Riken Center of AIP in Tokyo. I'm gonna elaborate on that. This is joint work with Florian Higet, who was visiting the lab. He's from Université Paris-Dauphine, and Hisashi Kashima is my professor in Kyoto University. I'm a postdoc, and everyone else is part of the organization called Mangaki I will talk about. So I'm really happy to share with you this work about how to use AI to recommend anime and manga using also the posters. So the Riken Center, so this is a lab, a public research lab institute on theoretical, applied, and ethical research, and we have a lab in Nihonbashi. So it's really close to Tokyo Station, so please come to visit if you want. So it's quite nice, and we got 8 accepted papers at NIPS last year, so this is the biggest conference in machine learning. And yeah, maybe one fun fact, we have more GPUs than researchers, like around 500 GPUs and 400 researchers. So Mangaki, I'm gonna talk about Mangaki, which is like a website to recommend anime and manga. So the idea is you rate anime and manga, and you can receive recommendations of what to watch next. So basically, you can rate the work by saying either I love this work, or I like this work, or neutral, or I don't like. Or if you don't know the work, you can say whether you want to see it or you don't want to see it. So these are the ratings you can have here. And by using this, we managed to collect 350,000 ratings by 2,000 users and 10,000 anime and manga. And so to do this, we had many APIs. So everything is open source. I will talk about it. But we used many APIs, including MyAnimalist, which actually who actually nuked their API because of the European regulations. So we have to come up with other ways to add data to the database. And we hope to use TV Tropes, which is another website, to gather more information about anime and manga. So the idea is like you just rate some works, so you can build a profile. So for example, I really like Steins Gate or Suzumiya Haruhi works, or I don't want to watch a certain scientific railgun S. And by adding elements to my watch list, I can ask Mangaki, okay, now what should I watch next? And it will reorder everything by saying, okay, now you should watch Pokemon, this movie, or Dimension W, or something like this. So I will explain how it works. So what can be done when you have 350,000 ratings? Of course, you can build a top 250 of every anime on time. So we used, so everything is written in Python and Vue. So we use the Django ORM on which we added some filters. So you can say like, I want to collect all the work and I want to find which ones are anime and I want to take the top 8, and you will get this list. But this is not what we're interested in Mangaki. Actually, we're a non-profit, and we feel like it should not be the blockbuster that gets all the fun. So maybe there is one anime that you should watch and that is designed for you, and we can help you find it. So everything is open source. We are driven by passion and everything. And so we use also Vue.js that I learned about by attending Hacker News Kansai, so I'm really happy. And there are many Jupyter notebooks on the GitHub, so you can check them. And we got some prizes from Microsoft Ventures and the Japan Foundation 2 years ago. So one idea that what can you do with 350,000 ratings, you can find what are the works that have few ratings, but most of them are likes. So you can come up with other filters, like, so this filter, we called it pearls, and which help us find some precious pearls like Moribito, Guardian of the Spirit, that few people know, but that is a really good anime. So this is some kind of idea that you can do, but you can also do recommendations. So I will explain what are the usual algorithms for recommendation. So mostly you can decide either you base it on content or on the ratings. So it's called collaborative filtering. So I will present 2 algorithms that are called alternating least squares and lasso. And then I will show the algorithm that we designed that uses the posters and some experiments. So the problem of recommender systems, so you have many people but that didn't watch every anime of course, you didn't watch 10,000 anime, you only watch 1% of them in average. So the idea is how can I infer the remaining ratings? So for example, if you have Sasha that loved Tokikake, which is this movie, and that didn't like The Martian, so I want to infer whether they will like or not Porco Rosso or Zootopia based on the ratings of other people. So what is a machine learning algorithm? Actually, it's some kind of function that it's a way, like you're trying to learn from data, so you're fitting on existing data, and you want to predict on new data what the outcome. So if you know that Ondine liked Zootopia and Ondine really loves Porco Rosso and so on, you want to know whether Ondine will like The Martian or not. So you want to come up with a function that outputs something like this. And so now, what is a bad machine learning algorithm? It's an algorithm that can learn completely the existing data, but that it will get it 100% correct, but it will get 20% correct on new data that you show to it. So if I predict dislike, but actually she really loved The Martian, I will get a really bad score for my machine learning algorithm. So it's a bad machine learning algorithm is an algorithm that cannot generalize to new data. So now what is a good machine learning algorithm? Actually, you can tolerate the fact that you cannot completely learn the existing data, but you get, like, let's say, 90% correct on existing data, and you can predict the remaining data 90% correct. So if I predict like for favorite, it's okay. It's close enough, and so on. So the usual technique that we use is either you're based on the ratings, or you're based on the work features, like the director and the genre. So I will present some of them. So like KNearest Neighbors and alternative in square. So please remember that ALS is for one algorithm and Lasso is another one. And then I will present what we did by building upon these two blocks. So let's say that I have a few people like Justin, Angela, Donald, Emmanuel, and Shinzo that watch some ratings, and I want to know whether Emmanuel will like Paprika. So I know existing data on other works. So what I can do is to try to find who are the nearest neighbors of Emmanuel. So it seems to be Angela and Justin because they agree on some movie that is about climate change, while actually Donald does not agree about climate change. And so based on that, you can see that you can learn that Emmanuel is close to Justin and Angela. And based on this information, so you can actually do this by loading the model. You want to find the neighbors of Emmanuel, and you will get Justin ID and Angela ID. So then, when I want to infer the node that Emmanuel will give to Paprika, I would like to have his two nearest neighbors that are Justin and Angela, but unfortunately, Angela did not watch Paprika, so I will take the third neighbor, which is Shinzo, and I will compute the average to say, okay, if Justin and Shinzo liked Paprika, maybe Emmanuel will like Paprika. So this is one way to do recommendation. And this is one way that is mostly used on e-commerce websites. Okay, it's called KNearest Neighbors. But we can, so now if I have many algorithms that do recommendation, I want to compare them. So for example, you can say, if dislike represent -2 or favorite is 4 and like is 2, I want to have a penalty. So if I predict favorite for favorite, no penalty. I got it correct. If I predict dislike for favorite, I will take the difference, like 4 minus -2, and I will take it to the square, and I will get an error of 36. So it's a terrible error. And if I predict like for favorite, it's okay, I only have 4 in error. So the error will be the mean value of this difference squared, and what I call RMSE is called the root mean squared error, so it's the square root of this. But basically, it's how far you were from the correct solution. So usually what we do in order to compare algorithm is you take all the ratings, you divide them into 5 blocks, and then you want to learn, you want to train on 80% of data, and you want to see whether you will get correct the remaining 20%. And maybe I was lucky, so I will do it again with this 80% and try to predict this. And this is called cross-validation, and this is a way to compare algorithms. Because based on this value, the lower the better. So matrix factorization is another way to do like collaborative filtering. So based on the ratings, only the ratings. I don't know what is Princess Mononoke. I just know whether Justin or Angela liked it. I want to learn whether a new person like Emmanuel will like paprika or not. So who here is familiar with word2vec? Have heard about it? Okay, so word2vec is like, sometimes you want to do the same for documents. You want to find which document is similar to this other one. So each of the words, actually, you can map it to a vector, and then you will get a vector and to which you can get some value to represent whether two documents will be close to each other or not. So we were going to do the same for users and movies. So basically, you have all the ratings, which is a big matrix like 2,000 to 10,000 that is filled only 1%. And you want to learn the position of the users and the position of the works. The works means manga or anime. So you want to compute this. You want to, like everything that is in orange should be learned. So, and then if I want to predict whether whether Emmanuel will like paprika, I will just have to take the vector of Emmanuel, the vector of paprika, compute the dot product, and then I can know whether he will like it or not. So there is an algorithm for that, which is called alternating least squares. So the idea is like, you just fix the users, learn the position of the movies, then fix the movies, learn the position for the users. So I'm going to show what it looks like. So you start with random points. So I displayed Death Note, Naruto, and Princess Mononoke. And then you want to learn the users. The users are in orange, and the movies are in blue. So this is called alternating least square because it tries to find which is the position of the users and the position of the movies that will reduce the error for the ratings. And then, hopefully, it will converge at some point. And then you will see like that you will have people that like Naruto and Death Note are not necessarily the same that like Princess Mononoke because it targets different ages, audiences. So this is something that you can do. So in the algorithm that we used, you don't actually directly minimize the RMSE because if you want to minimize it, you have a function like this. So usually what we do is like we minimize it plus something which is called regularization. So you have a smoother curve that you can easily optimize. But then once you have learned the position of all the vectors for all the movies, you can do this kind of nice map where you can see that people that like Spirited Away or Princess Mononoke or Totoro, which are Ghibli movies, are not the same people that like Naruto or Naruto. And what is amazing is here, everything was learned just by the ratings. The algorithm does not know who directed those movies. It's just based solely on the 350,000 likes that you can come up with this. So we have nice Jupyter notebooks, so you can do this kind of stuff and see where you are in the map. And if I know where you are in the map, I know what movies I should recommend to you. So, but the problem with that is if you don't have a rating, so like, let's say a new movie comes out, you don't know whether people will like it or not. So you can't find their position on the map. So you can't learn the vector. And if you have many movies that just come out, you have no way to distinguish between them. But we have many posters in Mangaki. So the idea is how can we use this to learn the position of the points. So there was a work by two Japanese researchers, Saito and Matsui, that developed a convolutional neural network that extract tags from pictures. So from manga illustrations. So for example, here you input just an image, and it can recognize that the image has red hair, and it's one girl with elbow gloves and a weapon. So for example, it gives you more information about the movie. So presumably, if you like movies with elbow gloves, I can recommend to you more movies with elbow gloves. And so this is like so it was pre-trained on ImageNet, which have many pictures. And then it was retrained on like 1.5 million manga illustrations labeled with tags. So it's really precious neural network. And yeah, it can output 500 different tags with weights. Like, so for example, like here you can see that elbow gloves is less likely to appear than there is one girl with high confidence. So what can we do once we have this data? So we can learn the preferences from a user. So it's an easier problem than the previous one because at least we have information about the work. So now I just want to know what kind of tags you are interested in. Are you interested in elbow gloves or are you interested in blonde hair or weapon? And actually I will have a constraint which is called lasso. That is that the user likes or hates really few tags. The other tags, they don't care about. So if I do this, I can predict whether you will like a new work or not, because if I have a new poster with tags, I will compute the dot product between this, and I can find out. So I can explain to the user, you seem to like magical girls, but not blonde hair, but this is a magical girl anime with brown hair, so you can buy it now. So this is something you can do. But so now we have two kind of algorithms, alternately squares that is on the ratings, the first one, and lasso that is on the tags. So the idea is, how can we combine them? So usually there are some boosting techniques that win machine learning competitions. But so the idea is to have compute some kind of average between the two predictions. But what we wanted to do is we know that if you have many ratings, maybe it's better to trust the first algorithm. And if you don't have many ratings, maybe it's better to trust the tags. So this is why we added this constraint on the weights. So I'm going to show examples of values for alpha. So first, here's the architecture. So you have posters from which you can extract tags, from which you can do recommendation, but you can also do recommendation with alternating least squares, where you only do it on the ratings. And then you want to combine them with this little block with beta and gamma. So here are some examples of alpha. So if you take only, you can either listen only to alternating least squares, or you can only listen to lasso, but this is not a nice blending. So what we would like to do is actually to say that if you have a certain number of ratings, okay, if the movie was rated by gamma people, you can listen to alternating least squares. Otherwise, you have to listen to lasso. But you cannot do this because it's not smooth enough. So you can come up with this kind of nice curve from which you can try to learn something. So basically, I want to learn which value from this block will provide the best prediction. So either I will have I will only listen to alternating least square or lasso or something in between. So this is what you do every time by iterations. And actually, we decided to call this the Stein's gate because it chooses the world line you are in, okay, to decide the prediction. And we call this model the Balusu as another reference to Manga. But anyway, so as I said, you can do a cross-validation to compare which of these algorithms will perform the best. And we used different types of movies, either the whole set of movies that are available on Mangaki, or the one that were the least rated, or work for which we didn't have any ratings in the training set. So we managed to show that Balusu managed to get a lower RMSE, so it's better than all the existing models, even for different types of types. So even notably if you have few ratings, it's better to listen to BALS than existing algorithm. Okay, so I can show you, so now that I showed how we managed to combine, this, I can show you future work. So for example, so why don't we let the neural network watch the anime for us? So because we don't have time. So you can watch the anime and tell me if it's good, because it's really easy to extract frame from episode. So then maybe in the future you can say, hey Pepper, what should I watch tonight? And maybe it will reply that if you watch Kansai, you can directly start at episode 12. Okay. So, and actually, I know that Netflix are making increasingly scary things with our data, or YouTube as well. And so hopefully if we do it in open source, it's nice. So you can have a look at the article, and on our GitHub we have many Jupyter notebooks, so I'm going to maybe show slightly, as I have a few times, so I will show a little demo. And actually we gave a keynote with other people who do artificial intelligence for manga in anime in Los Angeles earlier this month. So these people are doing actually manga transfer. So you give it to it a picture and it gives a manga version of you. So the slides will be on this link, research.mangaki.fr. Yeah, so here is, for example, so I have a few things that I can show for demo. So here is, for example, some kind of representation you can learn for the movies. And as I was lazy, I didn't put any background except the map of France. But actually, if it was a white background, it would be the same, right? So the location of the point has nothing to do with the cities, but it's nicer this way. So here you can see that, so this was learned only on the ratings. So here you can see that you have Clannad works near Paris, or these works that are like, close points means it's similar anime. So you have Fate Stay Night, Fate Zero, and something like this. And I don't remember where the Ghibli movies are. But here you can see that it managed to learn just from the rating that some points are close to each other. So this is more like high school movie and something like this. So this is on mangaki.map. We have on the GitHub, actually we have folders so where you can have all the algorithms. So here are alternating least squares. Okay, yeah. And also like some nice Jupyter notebooks where you can see the points, like here is Full Metal Alchemist, and so here is a duplicate of Full Metal Alchemist. Here is a sequel, and something like this. So thank you very much.
Question for the tags. How do you define the tag rating per user? Did they actually ask them to rate the tags?
So actually, this was a community website. Danbolu is a community website where people post a lot of pictures, and there are many people who manually add tags for them. So they use the whole thing to train it. Yeah.
Oh.
Yes.
Jill-Jenn, so the 0.79 means posters are more important than the ratings, or
0.79.
beta gamma.
Yeah. Okay. Yes. Okay. So what does 0.79 means? So it means like that if you have one rating, it's better to give more weights to alternating least squares, because if it was gamma equals 1, it means for like if you have a movie with only one rating, you can have 50% of alternate least squares and lasso. ALS. So this means, but it's the value of beta is really slow, so it's slowly increasing.
So are you only using the what they've rated it, or are there other factors that are being used as, like, for example, user demographic? Does that make a difference in ratings? Are you using them? I wasn't quite sure from the presentation. Like, are you saying that like a 17-year-old girl would probably be a lot easier to fit into a certain group, and then you'd have recommendations without needing the likes? Mm-hmm. So is that kind of data in there, or is it just this is all just based on their likes?
Yeah, it's just based on likes and learned. And actually, at the beginning, it was a choice. Like, we didn't want to get too much information from the user, so we just gave a Boolean that is like, do you want to watch Not Safe for Work or not? Because we had to do this, yeah. But actually, what is interesting, so it raises an important point, that is, are we discriminating girls and boys on our website? So we have no way to know this. So the problem is, like, with the European regulation, you want to take as little data as you can. But the problem is, if you don't want to discriminate, you should take as much data as you can. So if you want to ensure that you don't discriminate, actually we should ask people, what's your age, and are you a girl or a boy?
Could you use that to back, you use that to back up the data you have? Like, for example, if you know their age and that kind of thing, and maybe you would know from the manga, because that's some of it, and the anime is going to be targeted at like teenage girls or boys, or you might have that information. Is that something that you would ever use to compare your actual recommendation engine based on their choices, if they liked it or not, versus that?
Yeah, so like it would be tedious to do it by hand, like to map all the 10,000 anime. But if you have more data, it's better, because you can actually embed it to your like, for example, here we're learning the position, but you could have, so this is 20 dimension, but you can add one dimension that is age and one dimension that is like your gender and something. So yeah, we would add it, yeah, definitely. And it could learn that maybe this anime is for this kind of people by itself. Yes.
Yeah, so with this project specifically, did you run into any computational boundaries? Like, you couldn't do certain things because of computation power or cost, or was this all pretty easy to do?
Yeah, so this exact, like, you mean alternating least squares, or?
Just any part of it.
Yeah, okay.
You wanted to do, but it was too expensive.
Okay, I see. Nice question. Okay, so like, just to say, like, alternating least squares is like really something that was developed on TensorFlow and everything with efficient implementation. So it's actually what is, I guess, Spotify is doing something similar, or maybe they also listen to the music. They do something like this. And so this was not a problem. The problem is like, we don't have this data. So we can't reproduce. So what we would like to do is to train everything from the beginning, because indeed, like in Tokyo, we have like these 500 GPUs, so we would like to do this. And basically, I received a mail from someone that said, hey, I have 15 terabytes of manga illustrations. Do you want to take it? And actually, it was nice, but actually, most of the pictures were not safe for work, so I don't want to use like software funded by the government to run stuff on not safe for work pictures. So this is something that we could not do.
Okay, so just the data is not what you wanted, not the computation was not the limit.
Yeah, the computation was okay. And if you want to train this kind of stuff on high-dimensional data, yes, you need at least maybe one GPU. One GPU. Yes?
Why the name Mangaki?
Because manga and gaki means some kind of like bad child. Okay. Yeah, or maybe, so this was the main point. But yeah, and actually we are struggling to get internationalization. So we have a few pages in Japanese, like not everything is in English actually, sorry. But the repo is in English. Yes?
Aside from like ALS and LASSO, how do you choose which algorithm to use? How do you screen for?
Yeah, actually, LASSO was the best regularization we came up with. We tried other kinds, and so this is why we used this. And this was our best model at the time, so we used it. And now we use the factorization machine, and I think it could be a better way to combine everything. Yeah.
So from the ALS and LASSO, like the same score that you can just add, or do you have to like convert something else? Like you have the function earlier in the ALS and the LASSO, and you just like combine the score with that.
Yes, this is basically what we do. Yeah. We just like the prediction of BALS is this one, and then you just have to learn this, which are curves that say, if I have more ratings, I want more to go in this direction. That's it.
Correct me if I'm wrong, with all of your data sets that you're using are kind of English-based data sets?
Mm-hmm. Okay. Like the ratings come from mostly a French population.
All right, well, like, I mean, it's a foreign data set compared to Japan. Would it make sense to get also Japanese data sources, since most of the manga actually titles available are only in Japan? So it would be great to actually use that as a data source, so you can recommend stuff that's not out yet in foreign markets.
Yeah, okay. I see what you mean. Actually, this is something that actually AnyDB is quite new. Like they get the recent releases. Like it's community driven, so it's nice. I don't know any community website on the Japanese side. I saw one of them, but like JAddict or something like this. So yeah, we're happy enough with AnyDB, and it's funny that you mentioned this because like MangaBox, it's like some kind of website that. So yeah, it's some kind of website that where you can read manga on your smartphone, and they use illustration to vec actually to recommend works only based on the visual features. And I don't know, at the time they did not like this code was under MIT license, and they didn't mention it, but maybe now they do. I don't know. Yeah. So it will be a nice point. Okay. Yes.
I remember last time you said some people were trying to monetize your software, but you want to keep it open source and research focused. But is anyone licensing it or trying to use your research commercially?
So this is so we don't know, and this is under a GPL license for what it's worth. Yeah, it's GPL. But maybe we'll move to MIT if people are. If you can recommend us to that. Yeah, actually we do, but it's not like good enough. Yeah, you mean API for recommendation? Yes, definitely.
And you could, monetize it and still keep it basically for yourself.
Yes,
right?
actually, it's part of the project.
That's a gray area now.
Yeah. Ah, really?
Yeah. With
What?
the new GPL,
Ah, okay.
making an API is now a gray area.
Ah, okay. I guess. Okay. I don't know. Okay. Yes.
Sorry, I have another question. So theoretically, given if you had unlimited computing power and you had access to as much data as you needed, like, where's your dream recommendation? Where do you think it's possible to go? Like, how accurate do you think you can recommend anime and manga? Like, just theoretically, don't think in real terms now. Think like, how far do you think it can go?
Okay. Well,
Like, do you think you can accurately? You know what I mean? Yeah. No, but like, you know, we all know how Pepper works if you've ever used it. There's still a little bit to go there. So how far do you think it can actually go? Maybe in the next, like, say, 3 years, 5 years, and 10 years, or like, where do you reckon we can get there? Like,
so I guess maybe we can compare to like what Netflix does. Like, so for example, YouTube they do really great from a video. They do really great like hashing. So they what they call content ID. So it's a nice way for them to find which video is breaking the copyright infringements from this video, and maybe I can get a lot of money by doing something like this. So so this is something that they do. So like what we can. The problem actually with all of this is like it requires unfortunately a lot of human power, because you have two kind of stuff. Like either you have Wikidata that is like some kind of either you have data and you have ontologies. Okay, like you have this kind of community-powered knowledge about the works, and just like trying to learn from high-dimensional data as much as you can. So if we can combine them, this is something that we would like to do theoretically, because the problem is like, and actually it's part of the team I'm in Riken AIP, it's how to find a way to help crowd, like collaboratively help the system to work better. It's called human computation, and all the crowdsourcing stuff is related to this. And this is something I would be really interested in. Like, if you can have, try to harvest data from various kinds of sources to get this kind of information, like at the episode level. Something I should mention as well is like attention mechanism. It's like sometimes you can generate when you have a picture, you can generate a description for the picture that looks at, like, for example, if you say this is a cat playing with a boy, or a boy playing with a cat, you can, at the boy word, actually you can have the boy that is highlighted in the image. So, which means the neural network is actually looking at the boy by doing this. So we can do this kind of stuff on movies, and this is what I see today. Yeah. So it's not really done a lot.
And also maybe the neural nets can start making anime?
Yeah, of course. Actually, if you look at this, you will see like they generated faces of anime and something like this.
Yeah. Guaranteed to sell. So.
Yeah.
And actually, maybe I don't know if it's true, but maybe Netflix, like when they want to decide which kind of team they want to build, they use data from or maybe it would be nice to have Fincher doing something about politics with Kevin Spacey and something like this.
Probably good for artists, just as a storyboard starter, they could use this neural net to generate a basis for a story that's compelling or whatever, and then customize it to create something.
Yeah. So you can either generate faces. This is a work that tries to colorize. Like, this is a tool helping artists, like just by giving some colors, it can learn from existing pictures. And there was this other work on Manga Transfer.
One thing, since your data set has a popularity and all this mapping of different attributes, you can actually predict what's going to be popular as well, right?
You can predict the trends. But we tried to do this just with illustration to vec, but the tags were quite poor, because you just know there are multiple boys or multiple girls or like weapons. and it's hard to get information at this level. But
Not a good correlation there.
But yeah, at the end, maybe you don't want something that can predict what will be the next, because if producers start to look at it, they will stop.
But that's kind of what's happening in Hollywood, right? They're always producing the same kind of stuff because that's what people watch, right? Yeah, but that's the reality, right?
Yeah. Yeah, but I'm surprised how much like Netflix can manage to get precious pearl content. Like what is distributed by Netflix in anime is good quality anime or new anime. So I don't know how they manage to do this. Yeah. Okay, yes.
What would be the kind of data you would like to scrape, or what are you missing in your like?
Okay. Yeah. So the data that so here are some kind of website. Yeah. So something that we should do because we're a non-profit is like something that maps like this work on that has ID 30 on MyAnimalist equal this work that has ID 50 on my AnyDB, and this is something that they are doing quite a lot, but not enough. And so this would be something I would be really interested in gathering. And actually, they have a Sparkle endpoint. So TV Tropes actually tries to find what are the narrative terms that appear in many anime. For example, like Portal Door. Portal Door is just a door when you take it, you will get anywhere else. So Monsters, Inc. has this, or Stargate. So it managed to draw links between many works. Like you can, maybe by using this, you could recommend fantasy by anime or science fiction, something like this. So this is something really nice data point that I would like to play with. And we have many duplicates actually today, so we are using machine learning to remove the duplicates.
Maybe one last question before we close.
Yes.
Yeah. Are you doing freelance work as well?
Yes, actually, yes. For French, for the French Ministry of Education. Yeah. So we can talk about it. Yeah.
Thanks.
Thank you very much.